Hey everyone, this is going to be a simulation of an actual conversation between me and Deian. We're going to try to keep the profanity lower than their usual threshold, and shit-talking other networks also.
I see.
Lower, but not to an absolute zero. Okay. Cool. So, hey, I'm Tomer, a VP Product, SDF. Worked mostly on Soroban for the past couple of years. Who are you?
So I saw like when you sent me a list of like, hey, we might talk about this stuff, and I've been trying to answer that question for a while. I don't think I have a good answer, but I can tell you what I do.
Okay.
Maybe, yeah. So I guess I'm a professor at UCSD. I work on secure systems. I'm also a co-founder at Cubist, where we build, I guess the shortest version of it is an actually secure key manager. And I'm also a director at the Bytecode Alliance, and my group's been doing a bunch of WASM stuff, so I think that's maybe why, other than I'm kind of cool, you want to talk to me.
Kind of. Okay, so how did you get involved in the WASM? Because we are going to say you're part of Cubist. Cubist is a bridge bounty recipient. Just proper disclosure. Yeah, now.
How did I get into WASM?
Yeah.
It was like 5 a.m. We were working on sandboxing C code in Firefox, right? So like, think of your like crappy images or like really cute cat images. Like if I'm an attacker, I can just send you those images and I can pop your browser, and it turns out that like there's a bunch of really good companies that weaponize bugs in browsers to target people like journalists and so forth. So we were trying to like tackle that problem and kind of like figure out like, can we sandbox these crappy C libraries? So like we built this monster compiler hacking up an old NACL version, and this was like in 2018. And then we submitted a paper. We definitely didn't finish the paper, and we knew it was going to get rejected, but it was 5 a.m. And then we're like, you know what we could do? We can maybe use WebAssembly, because it seems like a thing. So this was like before WebAssembly like took like anything outside the browser. But we're like, it looks like a weird IR, where if you compile to WebAssembly and then compile WebAssembly to native code, you can kind of get the sandboxing property that you would get from classic SFI systems that basically do this. And then we just kind of took that 5 a.m. thing into like a real thing and built a bunch of compilers from WebAssembly to all kinds of things. And we're trying to make WebAssembly more secure and use WebAssembly for security.
Okay, and this was when?
This was like late 2018.
Okay, very cool. So the spec itself was finalized by that time, right?
The spec was in some form or another.
Form.
Yes.
Okay.
Yeah.
Cool. And just for people who are kind of like new to this world, can you give the primer on WebAssembly and why people should care about WASM?
Yeah. So I think WebAssembly is to me like a new way of thinking about how we build systems. And for me, I particularly care about secure systems, and it's kind of like a way of, the language has formal semantics, which is kind of unheard of in general, and it might be telling of the pitchfork days of and fire days of like writing C code and praying that it's good are kind of over, and we're starting to get towards the flying cars, but please don't make flying cars. So anyway, it's I think a new way of actually like building secure systems. So the way to think of WebAssembly is I think of it as a language, an intermediate language for security, but you can think of it in all kinds of different ways. So like, people care about WebAssembly hugely because of portability. So it's now an IR. If you compile it to WASM, you can run it anywhere. And we've done like fun things like run things in the browser in like a HoloLens goggles server side. So there's all kinds of places you can run WASM. So portability is a huge one. So like if we came up with a WebAssembly a little bit before Docker, we would all never use Docker, which would have been good. Wow. And the other huge bit is the determinism, right? If we try to like get security and portability across different architectures, we have to care about determinism, which is a huge deal, I would say, like outside of like the security space in general. So I love it as a compilation target.
Right, and you know, obviously WebAssembly was built for the web. Some people are pretty religious about the fact that it should stay in the web. And I think that the way we joined the Bytecode Alliance is a few months ago we were talking and you were saying, look, we really need another blockchain in the Bytecode Alliance to sorry if I'm disclosing stuff here. And so can you tell us a bit about this tension between, you know, the web, other applications like blockchains, like what does this actually boil down to?
Yeah, so that's a really good question. So yeah, I guess like my care for WebAssembly is actually totally outside of the browser, despite the work that we're using WebAssembly in the browser. But the browser use case is somewhat less interesting to me, even though it's like really important, right? Because like people are basically trying to say like, or like what people were doing, they're like, here's our gigantic app, we're gonna compile it to JavaScript. So we're taking Java and compiling it to JavaScript, which is kind of insane.
Offensive to an extent.
Yeah, it's super offensive.
Yeah.
So now we have WebAssembly, which is closer to the like what you actually want from a lower level kind of target language. But like, okay, there's a tension because now like the browser people are like, we want to compile our Java code. And what does that mean? Well, it means we need like
what does
a
a
garbage.
browser person look like?
Me? Well, except they're more opinionated about like supporting browsers. I'm like, it's like things outside the browser are more fun. So anyway, so like the big tension I think is coming down to like people are trying to compile higher level languages to WebAssembly and run them in the browser. And the other thing that comes with the browser is now we have to think about how do you compile these languages, but also we need to standardize across the browsers, and browsers have huge voices, which is in some sense good because we're coming to an agreement. In a different sense, it means that like people outside the browser need to start participating in browser conversations to like essentially express our concerns, I would say. Because if we don't, then we're going to get weird features. And the web has been cool, but also
idiosyncratic.
Yeah.
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 Cool. By the way, you can also ask me questions if you want. This is a two-way street. Yeah.
All right. Well, I guess like why WebAssembly and how I guess like when you're thinking about WebAssembly and this tension between browser and not browser, what are the features that you really care about and features that you really hate and features that you want?
Yeah, so I think, going back to the first step, why WebAssembly, to be quite honest, building a new smart contracts platform was not on our wish list, right? Like we would have been happy to just like grab something off the shelf and use it, but nothing really fit the bill. Obviously, the EVM is offensive for many other reasons. We're actually, and I iterated on some of these in the morning, but we have good friends in other ecosystems, and we have friends in Cosm, WASM, and Inc. We talk to all these people a lot, and we have folks from the near ecosystem that are building on Stellar. So, we're not, we love everyone. We just didn't really find something that was befitting of Soroban and our smart contracts. In terms of features, obviously, WASM 1.0 is a very slim spec, right? And so there's a lot left to be desired around things like how do you actually, communicate between different WASM programs. And so I think there's a lot of effort in the space. I would say that a lot of it doesn't really fit within our requirements of having like this like super optimized, compact way to move things around. Especially if you look at the proposed component. Is the component model finalized yet?
Ish.
Okay.
Not yet.
Yeah. So, when we started looking at the
We
component
finally have
model,
docs for it.
So the component model is kind of like the standard for how different WASM programs can actually communicate to one another, even if they're not written in the same programming language, which in theory is cool. It wasn't that finalized when we started this journey. I don't think it's finalized yet.
It's pretty close.
Okay,
So
cool.
I would say like you can use the component model today, and it's actually kind of solid.
But from our perspective, if you saw the Jay's talk and the internal of Soroban, everything is so, every bit is like accounted for. And when we looked at the component model, it was kind of like a bit offensive and just like how big things were moving around. And so serializing and deserializing is like one of the big reasons why we didn't actually go with like these other platforms out there, because I think if you look at WebAssembly platforms across the board, they do so much decoding, encoding and decoding. Like there's so many cycles being spent on that, which is quite absurd. And so
You mean between the host and the guest?
yeah, between the host and the guest, yeah.
There's a way to do it without that, but
You what?
there's a way to do it without that. That's safe, but sorry for interrupting.
I would love to learn about that. Yeah, so in terms of features, obviously we'd love for a lot of these things that we had to like build internally to be something standardized. And Soroban is built in a way that if new students do come in, like we can upgrade and we can create contracts with like the new standards. So we're happy to see more of that happening. On the runtime perspective, obviously we're running an interpreter right now. We're running WASM. which I think you gave me shit about that not so long ago.
I probably still will
Yeah,
forever.
okay.
Yeah.
So yeah, we would love for you to share that with the audience. So we're running an interpreter that's like super compact in terms of code. It's like, I think around on the order of magnitude of like 10,000 lines of code. So it's something that's very easy for us to work with. We definitely love to work with ahead of time compilation in the future. And I think WASM time is getting close to like the single pass compiler working. So we're definitely looking at that. But yeah, maybe you can share with the audience why running an interpreter is less than ideal.
Speed. Well, okay, so in this particular case, it's kind of an interesting, okay case, but I still think that once we get to like big enough programs, like you interpreting like really does actually start eating up into your actual app performance. The other bit is WASM is simple enough that we can actually compile it and make sure that we compiled it correctly or securely. And I would want this from your interpreter anyway. I want your interpreter to actually like use like page table hacks to make sure that like the interpreter, like if you have any interpreter bugs, they won't result in security bugs. But like with compilation in this particular case, it's like relatively simple that I think going from an interpreter to a compiler is pretty straightforward. I guess the other bit, maybe less so for definitely for the current version, but I think like one thing that I've seen is people just shove things into the runtime and they're like, this is WASM, and then they're like, here's this neural network thing that is massive and unsafe, and I'm like, well, we have a pretty good language that gives us sandboxing, so if we can use that to actually sandbox a bunch of the other things that would normally be host calls, but you don't put them as host calls today or you put them as host calls today because of performance, then you should compile that. Right, so you can imagine a world where like you're either doing ahead of time compilation or potentially even JITted. JITted gets scary in different ways, but
yeah, yeah. So there's a lot of different ways in which JITs are scary. We actually we put out a blog post a few months ago that's called "Why Soroban Doesn't Use a JIT," which describes exactly that. And I highly recommend taking a look at that. This is definitely not the final iteration, and I do believe that in the future we're going to move on to kind of like more performant technologies. With that said, because Soroban has such a strong reliance on host functionality, and a lot of the kind of like mission critical code actually runs on the host, it's not such a hit on performance. I would, at one point, would love to open this up for questions from the audience. One last topic I want to talk about is the actual source programming languages. So right now, we're using Rust.
Yep.
I explained this morning, we think that Rust is kind of like probably the best kind of like WASM source language available today. Would you agree with that? Is that going to change?
I completely agree. Look, we can just give up on JavaScript. Compiling JavaScript to run on WebAssembly is weird, even though people want it.
Right, if like a certain blockchain that does weird things.
I said
like that.
no such thing.
Yeah, okay, yeah.
Yeah, so I mean, the reality is like, yeah, C, Rust, C++, great targets for WASM, partly and it was almost, if you look at the design of WASM, it's kind of like really good at this, right? You have a linear memory, you have simple instructions, really easy to like compile programs, and you don't have a huge runtime. So like that means that if you're trying to compile a high-level language today, it's not great for many reasons. One is that you can't like just like hack pointers to make your like GC fast, right? So you could, but like your Go or like Java implementation will be like dog slow. This is changing with new features like the GC. So like the GC extension, for example, exactly is meant to help you compile things like Java or Kotlin, which I've never looked at, but it's a thing apparently. And you have basically the GC implemented into runtime itself. So like that's kind of like a good mix of like the language is still relatively clean. You can bring a garbage collector as a sidecar and go from there. So I think like we're going to see a lot more languages because like especially the web people want this, and like really like if you look at serverless platforms and things like that, you want to write your program in whatever language you kind of want to.
Right, and so the interesting thing there is that this kind of like takes a step towards the more traditional programming languages. In the world of the more kind of like safe programming languages, like one issue that we do have with Rust is that it was definitely not designed to produce small, executable blobs, right? So are we going to see anything that's like more geared towards actual like compact programs?
This is a good question for the Rust team.
Yeah.
I would love it because my compilation times suck. Yeah, I mean, my suspicion is yes, and I think partly because we're still on the upwards trend of WASM being used in settings where normally you would do, like, you'd use a container.
Yeah.
So, I think like the speed up time really starts mattering, and this is both like in like these platforms, but also like in the blockchain space, right? Like if suddenly like you're spending a bunch of time getting your program up and going, that's kind of a pain.
Yeah.
So yeah, the constraints I think are probably making their way onto the Rust team, and I think there's a nice overlap between the Rust folks and the WASM folks that we're seeing.
We're seeing some excitement in the SDF and in the ecosystem around Zig. What do you think about that?
Yes.
Yes? You're into that?
Well,
What is Zig?
Zig is a new language designed to be safe. It has a less fancy type system than Rust, I guess, is one big thing. And the nice bit is it does kind of have WASM almost built in, where you can bring in a bunch of code that's unsafe and use it. I'm still not convinced that you would interface with that code correctly and safely, because that's always kind of the hard part, is I have a sandbox code and then like you're like just pretending that the interface doesn't matter, and that really does actually matter. It's a nice, I don't know, like language and going on the safe route. I'm personally like done. Rust is it.
Good stuff. We have almost 3 minutes left, and if the audience has any questions, we're happy to take some questions. Morgan over there is raising their hand, and Willem too. Morgan?
Thank you. So Soroban does run in the browser in one instance, so the web connection is there, and I love the web. The dream for me is to be able to run the Rust compiler in the web. Is there, so that I can close the loop and people don't need to go to cargo and whatnot. Is that dream real? Can I make it happen, or what's the status?
You probably can't make it happen today. I don't think the tooling is there yet. In fact, like if you try to compile many, like even things like SQLite, it's a little bit of a pain in the ass, right? And part of this is coming down to not actually WASM itself, but it's the interface with the outside world, right? So like if you take your Rust compiler, it assumes POSIX basically, or the equivalent of that on Windows, which we don't need to know about. So like we need to actually like implement these standard libraries. The compiler itself is like a monster, so I think like it'll take a while to get there, especially if you're using the LLVM backend, right? Like compiling LLVM to WASM. We should talk to the Chemu person. They'll probably do it for us.
Willem? Raise your hand. Yep.
Hi. Yeah. So you said that there was the side trade-off when deciding whether or not to use an interpreter versus a ahead-of-time compilation. So like the max for a Soroban is what, 64 kilobytes? What, where do you, is that on that threshold, or can we just kind of, basically, is it worth the extra complication for the small amount of performance?
Well, are you asking about like the size reductions?
Well, just in general, where's that line? Like you said, is the small, if it's small enough, an interpreter is good enough. So like, is it 60 kilobytes? Is it 100 kilobytes? Sort of, where is that number?
Yes, I can't give you a straight answer for that, but I can tell you that as we're working towards caching contracts, whether it's within the scope of a transaction or within the scope of a ledger, or even more than that, then the gains start to become more and more substantial.
Okay.
Just a second. You need a mic?
Hello, I'm Joseph from Switzerland. Are there specific security risks when using a WebAssembly? Known security risks associated already?
You've done some work on verifying WASM runtimes. What can you tell us about the security characteristics?
So it depends on like what runtime you're using to start, right? So like just compiling to WebAssembly doesn't really give you security. Even though people think it gives you memory safety, partly because of the description, it really doesn't. So if you take C code, compile it to WASM, it's still shitty. So like you're still going to have classic bugs. You're not going to have like return-oriented programming type attacks, but you're going to have all kinds of other attacks. Basically, like we'll be able to pop your machine. The nice part about WASM, it's so simple. Many people implemented runtimes. The downside of that is most of those runtimes are actually insecure. So
Encouraging.
yeah, well, software. But I think like to start, like if you're building a new WASM runtime, like maybe do it in Rust instead of in other languages. So that's like one easy way to make sure that a bunch of bugs go away. You still need to make sure that when a piece of WASM code calls into the runtime, that runtime is properly handling those inputs essentially and validating them, so that you can't like have one WASM sandbox suddenly corrupt a different sandbox by calling into the operating system, right? So and there are ways to deal with this in a principled way, and I would say like there are a handful of runtimes that do it pretty well, including Soroban. So people have thought about this. So I think in general, like the safety there is, the safety net is pretty good. And if you're trying to like run untrusted code, it is actually a really good sandbox. You just have to pick your right compiler, right runtime.
Okay, the monitor is screaming at us that we're over time. So thank you so much. You
Thank
can
you.
talk to us outside. Thank you, Deian.
Thank you for having me.
Thanks, Connor. Thanks, Deian.